Log aggregation is the practice of collecting, consolidating, and centralizing logs from across your entire Kubernetes cluster. In a distributed environment with multiple nodes, pods, and containers, log aggregation brings all these scattered logs together into a single, unified view. This makes it much easier to monitor your applications, troubleshoot issues, and understand what's happening across your entire infrastructure. There are 3 critical reasons why log aggregation is essential in Kubernetes. First, it provides centralized visibility, giving you a single place to view logs from all nodes and pods instead of checking each one individually. Second, it simplifies troubleshooting by allowing you to track requests as they flow through your distributed microservices architecture. And third, it ensures persistent storage, meaning your logs survive even when pods restart or nodes fail, which is crucial since containers in Kubernetes are ephemeral by nature. Kubernetes offers 3 main patterns for collecting logs. The node-level logging pattern uses a DaemonSet to deploy a logging agent on every node in your cluster. The Sidecar pattern places a dedicated logging container alongside your application container within the same pod. And the application-level pattern has your applications send logs directly to the aggregation backend. Each pattern has its own advantages depending on your specific requirements and infrastructure design. Here's an example of configuring node-level logging using a DaemonSet. The API version is apps/v1, and the kind is DaemonSet. In the metadata section, we name it Fluentd and place it in the kubesystem namespace. The spec section defines the selector with match labels using app:/Fluentd. This configuration ensures that Fluentd runs as a daemon on every node, automatically collecting logs from all containers on that node. To access logs from the host node, the logging agent needs proper volume mounts. The volume mount section defines 2 critical paths. First, we mount the varlog directory to access system logs. Second, we mount var/lib/docker/containers as read-only to access container logs. In the volumes section, we specify that varlog comes from the host path /var/log. This configuration gives the logging agent access to all log files generated by containers running on the node. 3 popular stacks dominate Kubernetes log aggregation. The EFK stack combines Elasticsearch for storage and search, Fluentd for log collection and distribution, and Kibana for visualization. The ELK stack is similar, but uses Logstash instead of Fluentd for log processing. The PLG stack uses Promtail for log collection, Loki for lightweight log aggregation, and Grafana for visualization. Each stack has different resource requirements and feature sets, so choose based on your specific needs and infrastructure constraints. When implementing log aggregation, focus on 3 key areas. Log enrichment means adding metadata like namespace, pod name, node information, and labels to make logs more searchable and contextual. Filtering and parsing involves structuring your logs and removing unnecessary noise before storage to reduce costs and improve query performance. Resource management requires setting CPU and memory limits for your logging agents to prevent them from consuming too many resources and impacting your application workloads. Follow these 4 best practices for effective log aggregation. Use structured logging with JSON format to make parsing and querying much easier. Implement security and compliance measures by encrypting logs in transit and masking sensitive data like passwords or personal information. Define retention policies with lifecycle rules based on your compliance requirements and storage costs. Finally, optimize performance by using buffering and batch processing to reduce the overhead on your cluster and improve the efficiency of log shipping.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.